all, how are you? Today we will discuss about the time period of loaded spring with consideration of mass of spring. Already we know the time period of loaded spring T equal to 2 pi root over m by k, but here m is a mass of loaded block. Let me draw the diagram. The spring is, one end of spring is attached to rigid support and other end is mass of block, it is m. If mass of block is considered, then already we know the time period of this oscillating spring T equal to 2 pi root over m by k, where k is spring constant or force constant of the given spring. But here now I am calculating the time period of the system with consideration of mass of spring. Let mass of spring, it is taken as ms. Ms is a mass of spring. Then how the time period of the system is going to be changed. So consider a spring system, mass of spring it is ms, and suspended mass it is m, and force constant of the spring it is k. Okay, and consider a small length element dy. Dy is a very small length element dy, and total length of the spring it is taken as L. So what is the mass per unit length? Mass per unit length of the spring. Total mass it is ms, total length it is L. So mass per unit length becomes ms by L. Now I am calculating what is the instantaneous kinetic energy of the spring. When you pull this block and release, it is going to be oscillates. So nothing but having kinetic as well as potential energies. Potential energy equation already you know of kx square. K is a displacement. Now I am calculating instantaneous velocity, kinetic energy of the spring. Spring I am calculating. Then after total kinetic energy, the next step it's potential energy, then after total energy. Okay, let me repeat again. Here instantaneous kinetic energy of the spring, then total energy, and the next step it is potential energy, then last step it is kinetic sum of the potential kinetic, it is total energy. So kinetic energy expression already we know, k equal to of mv square is a general expression for kinetic energy. M is mass of the system, here mass of the spring. Okay, so kinetic energy of the spring k equal to of mass per unit length m by L into dy. Dy is nothing but mass of this portion. This is of m. Now v is a velocity. Velocity of this given portion, small section, it is equal to y by L into dx by dt. Dx by dt is nothing but velocity and having square. This is totally v square of m v square. So for total spring means you have to apply the integration from 0 to total length. 0 to total length of the spring it is L. Now integrating kinetic energy k equal to of ms L, and here L square nothing but L cube okay, and dx by dt whole square, these are constant taken out from integration, and integration from 0 to L, here y square and dy, y square into dy, that is kinetic energy K equal to of ms by L cube dx by dt whole square, into integration of y square dy is nothing but y cube by 3 limits 0 to L, that is K equal to of ms by L cube dx by dt whole square. Here applying the limit, upper limit is L and lower limit is 0. So after applying the limit, we will get L cube by 3, and L cube, of course, L cube is going to be cancelled out. Then remaining the kinetic energy of the spring K of ms, here 2 into 3, 2 3s are 6, 1 by 6 ms dx by dt whole square. So now I am calculating what is the total kinetic energy of the system. Kinetic energy of the system. Kinetic energy of the system means kinetic energy of the spring as well as kinetic energy of the block. So total kinetic energy means K equal to spring, already we derived, of 1 by 6 ms dx by dt whole square plus block kinetic energy of mv square. M is mass of block, v is again dx by dt whole square. So same equation can be done as here dx by dt whole square taken out as a common, then K equal to of is of as well as dx by dt whole square taken as common, then remaining it is m mass of the block ms by 3 and dx by dt whole square. This is kinetic energy of the system. And potential energy, energy of the system U equal to of K x square, where K is K is a force constant and x is a displacement of the spring. Therefore total energy is the next step. It is total energy. Total energy means kinetic energy plus potential energy, that is E equal to kinetic energy already we derived of ms by 3 dx by dt whole square plus potential energy we know of K x square. But according to law of conservation of energy, total energy remains constant, neither be created nor be destroyed, but changes from one form to another form. Total amount of energy remains constant. Total energy remains constant means the differentiation I am taking, right? So the energy is differentiating dE by dt equal to 0. Total energy constant means its first order differentiation is equals to 0. So applying the differentiation for total energy, that is d by dt of total energy, that is of m plus ms by 3 dx by dt whole square plus k x square, which is equals to 0. So of m plus ms by 3 is a constant taken out. Of ms by 3 is constant. So d by dt of, let us say taken as totally as x. So d by dt of x square nothing but 2x. So it is 2 into dx by dt. Again d by dt of dx by dt, it becomes d square x by dt square plus of k d by dt of x square. X square, it is nothing but 2x, again dx by dt, which is equals to 0. So from these two terms, 2 dx by dt, 2 dx by dt, of course of also is taken as a common. So here it is of cancelled, 2 is cancelled, then dx by dt is taken as a common, remaining m plus ms by 3 d square x by dt square plus k kx dx by dt equal to 0. So dx by dt taken out, it becomes 0, remaining m plus ms by 3 d square x by dt square plus kx is equal to 0, or same equation can be written as d square x by dt square plus k by m plus ms by 3 into x is equals to 0. So this is the equation we got when you consider the mass of the spring, and this is similar to SHM, simple harmonic equation. What is a simple harmonic equation? D square x by dt square plus omega square x is equals to 0. If we compare this equation with the simple harmonic motion, in a place of omega square, which is equals to k by m plus ms by 3, or omega becomes root over k by m plus ms by 3. Omega in terms of time period, it is 2 pi by t, which is equals to root over same k by m by 3. So therefore the time period can be written as t equal to 2 pi root over m plus m by 3 is ms by 3, mass of spring, okay, is ms by 3, and by k. This is the time period of the loaded spring. If we consider the mass of spring, if mass of spring is neglected, mass of spring it is very small, which is neglected, then the time period becomes 2 pi root over, only will take mass of block by k, m by k. Thank you.